Your digital multimeter can measure voltages, currents, and resistances in loads, power supplies, and circuits in general. While the proper port/lead alignment is important, the selection knob will help you select the most accurate measurements. When working with DC projects, you can measure the voltage by guiding the rotary switch through the V for voltage function of the wheel. The DC or direct current voltage function typically has a line and 3 dots next to the V. Within the voltage function, there are different ranges listed. This multimeter can read between 200 millivolts and 600 volts. These values represent the maximum voltage that can be measured at that range. Scroll until you find an appropriately rounded voltage with appropriate significant figures. If your multimeter reads 1, your setting is too high or too low. The unit of your measurement comes from the unit on the selected range. In order to measure the current, scroll the selection knob to the A for current function of the wheel. Within the current function, there are different ranges listed. This multimeter can read between 200 microamps up to 10 amps. These values represent the maximum current that can be measured at that range. Scroll until you find an appropriately rounded current with appropriate significant figures. If your multimeter reads 1, your setting may be too high or too low. The unit of your measurement always derives from the unit in the range that you've selected. Your digital multimeter's selection knob may be organized differently, but it's designed to measure the same variables. You will always be able to find voltage, current, and resistance labeled on the outer edges of the selection knob. Each multimeter will take up a portion of the selection knob's outer ring, but they may not always be in the same order as other multimeter models. In some cases, these measurements will have color-coordinated labels or may be organized by a colored portion of the knob's inner ring. The innermost labels indicate the maximum voltage, current, and resistance for each measurement. Although there are commonalities across multimeters, always check your digital multimeter's maximum values. We've explored the individual parts, but let's put it all together and measure some currents and voltages. Let's explore how to connect your multimeter to measure the open circuit voltage and current of a solar panel. The solar panel has red positive anode and a black negative cathode. The multimeter has a red positive lead and a black negative lead. The probes of your leads should align with the circuit's polarity and color-coordinated organization. You can touch the probes temporarily to the circuit to measure values within the circuit. However, if you need to measure ongoing data, alligator clips allow a more permanent solution. Connect the alligator clips together between the probe tip and the anode or cathode. Make sure the anodes connect to the anodes, the cathodes connect to the cathodes. I'm only measuring voltage at the moment, and I anticipate a low current. So my red banana jack is in the volts, ohms, milliamps port. As I scroll through my selection knob, I may choose a range that's too low, in this case 200 millivolts or 2 millivolts. The multimeter will display a 1 or some kind of inconsistent decimal. This tells me that the solar panel's open circuit voltage has to be greater than 2 volts. When the selection knob is set to the 20 volts range, a constant and properly rounded voltage reads on the display. Depending on the voltage, you may need to check ranges above or below to confirm you found the best maximum voltage setting. Since the unit for this range is volts, the open circuit voltage of this solar panel is about 2.9 volts. To measure the short circuit current of this solar panel, scroll through the current ranges on the selection knob. The 10 amp, 200 milliamp, and 20 milliamp ranges all provide a number close to 0, so the range is set too high. As I scroll towards the 200 microamp range, a value with more realistic significant figures starts to appear. The 200 microamp range provides the most significant figures. Since the unit for this range is microamps, the short circuit current of this solar panel is about 84 microamps. You can repeat this process with other multimeter models, as long as your ports are connected correctly and you can locate the voltage and current ranges on the selection knob. Scroll through the voltage and current ranges on the selection knob to find the most accurately rounded value. If your multimeter is providing inconsistent readings in an optimum setup, check your probes. Since we've observed that this current is significantly less than 10 amps, the red lead is in the incorrect port. Once it's corrected, the selection knob can easily read the voltage and current. The configuration of your multimeter's connection within a circuit will always be specific to that project. This can be based on the design and requirements of the load or components. If your project comes with instructions, always read the suggested multimeter settings carefully. However, even with these settings, you may have to adjust your selection knob ranges to find the most accurate data. If you're working with a higher current, above 200 milliamps, closer to 10 amps, you'll need to use both ports on your multimeter. In order to measure this battery pack's voltage, keep the red lead in the volts, ohms, milliamps port and use the selection knob to measure the voltage. If the current of the battery is higher than 200 milliamps, the multimeter will read zeros or inconsistent values. Once you've switched the red lead to the 10 amp DC port, turn the selection knob to the 10 amp or highest range. The 10 amp setting on the selection knob and the 10 amp port are used together to read currents at this range. Other multimeters will follow the same process, but the labels on the selection knob and the port location may change. Keep the red lead in the volts, ohms, milliamps port in order to measure the voltage. To read current, switch the red lead to the 10 amp DC port and select the 10 amp range on the selection knob. Although most hands-on STEM activities will have suggested multimeter settings, the multimeter will guide you towards the most accurate measurement. A current reading of 1 means that selection knob range is too low. If you can't get an accurate reading by turning the selection knob, it's a sign that you need to change the red leads port. If you're changing between power sources, loads, or circuits, your leads may be disconnected or disorganized. Always make sure that your connections are consistent. A measurement of 0 commonly means that the multimeter is not part of the circuit, not connected. This can happen when alligator clips break, become unclipped, or your probes are just not touching a conductive surface within that circuit.